Alright, so here we are with the 5-2 notes. We're going to prove trig identities. What we'd been doing before was kind of simplifying or solving them, but now we are going to prove them. So, when it comes to proving trig identities, the idea is that now you will have something like cosecant, whoops, that's not a C. Well, I'll just flip to the next page. You'll have something that basically just has an equal sign there, okay? And so when they say things like, to prove an identity, the rule for proving an identity is to make one side of the identity look like the other. But while you do that, you can only work from one side. That's not to mean that a strategy isn't go to the answer, if you will, and try to work backwards. The idea is that you would pick one of the more complicated sides and try to actually simplify it. This definitely looks like a lot more symbols going on than that one, so I might start on this side and try to change it to match. So, some strategies. There are no formulas necessarily for this like step process, but you just have to try things and be creative and identify properties of algebra. So, the first thing of your strategies is to look for the more complicated side and try to fix that one to become simpler. Another idea, and we've kind of done it already, is change all trig functions to sine and cosine. So go ahead and change all your cosecants and secants and so that everything is just sines and cosines, and see if you can start canceling or moving things around. Another option would be to combine fractions by making common denominators, so we have done that in our previous lessons. Factor or multiply, so that idea of multiplying by a version of 1 to simplify something, maybe get rid of a denominator or something like that. Another one is actually identities of factoring, so for instance knowing that something is a difference of squares is always helpful. And then we also have kind of that idea of what is the target or where is the end of this in order to figure out what the solution could be. So always thinking of I'm trying to get to a cotangent or whatever it is so that you don't kind of go overboard with your simplifying. So again, these are all strategies that hopefully now that you see them, you've used in our previous lesson, and so now we just kind of need to know they're there and walk through them. So, taking a look at number 1, again, the first thing that I'm going to do is probably understand that I can rewrite my cosecant, for instance, as 1 over tangent, so that idea of making things into sine and cosine. So I have 1 over sine, and that's going to be multiplied into cosine plus sine plus, sine of x plus sine squared of x. Alright, and then I'm going to distribute that sine into everything here, so now I have cosine x over sine x plus sine x over sine x, and then plus sine squared x over sine. And hopefully you can now see that cosine over sine actually becomes cotangent. Sine over sine becomes 1, and sine squared over sine cancels, and so you have 1 sine, so plus sine. And so we now have our equal, and the original phrase that we wanted it to equal. So notice that I did not do anything to this side, but I did make this side look like it through these steps. Alright, so that's the whole point. Pick one side, change it up, and make it look like the other side. Alright, our next example, we've got some cotangents and cosines on the left, and then all of a sudden we have cosine times cotangent on the right. So, let's see how we want to walk through this one. I think the first thing I'm going to do is change everything into cosines and sines. Yep. So in cotangent over here, I'm going to recreate that as cosine squared of x over sine squared of x, and then have that subtracting cosine squared of x. Now the idea, of course, is that I want this to have a common denominator, so I'm going to multiply by, as we have in this one, a clever 1. So I'm going to multiply by sine squared, because this one has a sine squared bottom, over sine squared. And so now I'm going to have cosine squared of x over sine squared of x minus cosine squared x sine squared x over sine squared x. So now everything has the same common denominator, and now I can actually combine it so that there's a 1 numerator okay. Then hopefully you can realize that in the top I was writing a bunch of cosines, so I'm going to take that cosine out front. And so I'm going to have a cosine squared of x out front, and then a 1 minus sine squared, and then all of that over sine squared of x. 1 minus sine squared from your Pythagorean identity is going to be cosine squared. And so we end up with cosine squared times cosine squared over sine squared. And then cosine and sine make cotangent, and cosine squared of x is still there. And of course those are backwards, but we know that multiplication is commutative, so. Alright, that one was interesting. Alright, so the next one here, we've got a tangent and some secants. Alright, so what I'm going to do first is, where's the one that says it? This one's not actually on here, but multiplying by the conjugate. It's technically this one. So if I take a look at this one, what I'm going to do is multiply by secant plus 1, because notice plus and minus are the opposite, that's its conjugate. And then we've got secant x plus 1 here as well. So if I multiply by secant squared plus 1 on the top, I have secant x tangent x plus tangent x. And then on the bottom, I get secant squared. Well, let's see where we get it from. You get secant x plus 1, and then secant x minus 1. And so it becomes secant squared x, secant x minus secant x, which will cancel, and then a negative 1. So that denominator is going to become secant squared x minus 1. Alright. So then by a Pythagorean identity, we now have secant of x tangent of x plus tangent of x. And so why would I want to do that? Because I was noticing that I have a bunch of tangents, and if I change secant into tangent squared on the bottom, then I can actually make these into separate fractions. So I can make it into a fraction of secant x tangent x over tangent squared, and then plus tangent x over tangent squared. And so what does that do? It now means that we have a tangent that cancels, so there's only 1 there. A tangent here that cancels, so there's only 1 there. And so we'll have secant of x plus 1 over tangent of x, which of course is cotangent. And actually we didn't need that. Oh, this is still over tangent. And so since they're both over tangent, we can actually take secant of x plus 1 and just put it all over tangent, 1 denominator. And so now we look like the top. Boop. Lots of arrows there. Alright, so lots of kind of algebra just sitting there. Alright, and our next one, let's see, definitely have a bunch of things that aren't sines and cosines really, but then over here, yeah, so I may as well change them into sines and cosines. So tangent is sine of x over cosine of x, and then cotangent is cosine of x over sine of x. But then, of course, I do want a common denominator to be able to add these. So I'm going to, have to multiply by cosine, top and bottom here, and sine, top and bottom here. And so if we do that, our top becomes sine squared x sine cosine plus cosine squared x sine cosine. And so on our numerator, it becomes sine squared plus cosine squared, which hopefully we can see automatically as our Pythagorean identity of 1. And so this numerator becomes 1 by your Pythagorean identity. And so then we end up with 1 over sine x cosine x. And that's almost the end because, of course, that's 1 over sine, which is cosecant, times 1 over cosine, which is secant. And so 1 over sine becomes cosecant and times secant. There it is. Boop, boop, boop. Which, of course, is backwards, but multiplying is commutative. Alright. So let's see our next one. Ooh. Kind of a lot going on. As much as we have been using a lot of this left side, I'm actually going to do the right side, because notice that if I multiply this side, for instance, by secant of x minus 1, I'm actually multiplying by its conjugate. So that's exciting. And then over here, I'm going to multiply by secant of x plus 1. And so if I do that, I end up with secant of x plus 1 on top, but then multiplying out secant x and secant x minus 1. These will cancel, and we'll get secant squared of x. So our denominator is secant squared of x minus 1, and this one is secant x minus 1, and secant squared x minus 1. Alright. So then if we put it all in one fraction, because now they have the same denominator, I have secant x plus 1 plus secant x minus 1, and so my plus 1 and my minus 1 will cancel, and so I actually have 2 secants of x on top and secant squared of x minus 1 on bottom. And of course our Pythagorean identity tells us that secant squared of x actually equals tangent squared. And so we end up with 2 secant x over tangent squared x. But that's not quite what the numerator has. Notice they have cotangent and cosecant. So if I rewrite these so that I actually have all of the pieces kind of separated, we have a 2. A secant is actually 1 over cosine. And tangent is sine over cosine. Oh, sine squared over cosine squared. Oh, I did that kind of funky. Okay, we'll do it a different way. If we want to bring this up, or flip it, that makes it cotangent, and so that's how we're going to get cotangent squared. You can do it algebraically, but how did I get cotangent squared and the other one just has tangent? Let's see. Oh, so I did want to do that. Okay, let's erase this red. Okay. And then this was supposed to be over tangent squared. Okay. So it is 2 over 1 and 1 over cosine. And then because it's over tangent, that actually means that we're talking about the flip of tangent to bring it up top. So it's going to be cosine squared of x over sine squared of x. And so I'm going to cancel a cosine, so there's 1. And so if I rewrite that, I get 2, and then there's 1 cosine on top, and 2 sines on bottom. And so cosine over sine is your cotangent. 1 over sine is your cosecant. And then, of course, 2. Alright. That works. Okay. And then our second to last one here. Alright, let's see. I see a 1 minus sign, and there's no squareds or anything like that, so I'll probably be multiplying this left side by 1 plus sine t, meaning the conjugate. So if I multiply that out, we get cosine of t from cosine times 1, and then cosine sine, sine t cosine t, over 1 minus sine squared t. And then 1 minus sine squared t by the Pythagorean identity is cosine squared t. And then our numerator, oh, I shouldn't have factored that out, boo. So I'm going to bring out the cosine again. So I'm just going to pretend that we didn't factor this out and just have the cosine t times 1 minus sine t. Alright. So cosine t and 1 minus sine t means that one of our cosines cancels. And so now we have 1 minus sine t over cosine t, which is what they wanted. Yay! Alright, and then the last one here, I see a denominator that we could make a conjugate, but I also see a lot of secants, cotangents, and tangents, so I'm going to just rewrite it all as sines and cosines and go from there. Alright, so let's see, cotangent of u is really cosine over sine, and that's going to be multiplied by secant, which is 1 over cosine, and tangent, which is sine over cosine. Alright, then we're going to distribute this guy here, and so we end up with cosine u sine u cosine u minus cosine u sine u cosine, oh, sine cosine. Alright, so hopefully you can see that that numerator and denominator are the same, so that's a 1. These cosines cancel, and so we end up with 1 over sine of u. Alright, let's see. Alright, so let's see. That ends up being cosecant u minus 1. Which is pretty close to what we're trying to get up there. But in order to get there, I do need a 1 plus cosecant on the bottom. So I'm going to multiply the top and bottom by a form of 1. So cosecant u plus 1 and cosecant u plus 1. And so I end up with cosecant u squared, cosecant squared u minus 1. If you want to do the box for that one, you have cosecant u negative 1, cosecant u plus 1, and you're multiplying them out, and you get cosecant squared u, and then negative cosecant, which I crossed out, and positive cosecant. Anyway, these two cancel. And so that's my new numerator. And then the denominator is cosecant u plus 1, and then via Pythagorean identity, that top actually becomes, what is it, cotangent. And then it's cosecant u plus 1. Woohoo! Which is what we wanted from the beginning there. If you had a more exciting way to get there, awesome. Okay. So I did also change the assignment from 11 through 51 to 11 through 39, and not even odds, it was by threes. So anyway, it'll be, I made a worksheet for it, so it'll be there for you. Sweet, so that was interesting. Anyway, so those are the kind of strategies. So if you get stuck, did you change everything to sine and cosine? Did you multiply by a reciprocal, whatever it happens to be, or a conjugate? So 5-2.